Okay, let's continue this 7.6 integration topic. So now, before, as I told you, the questions require completing skill, okay? And I have done one question for your reference, how we give the completing skill. I think please now is 7124, same pattern. Please, we require, first of all, completing squares. Now, 85 to 94, they are one group of question with same concept. And what is the concept is? The concept is that substitution. Step one, we use substitution. Let's take a couple of questions, then we start last section 7.7, please. For example, we can start with 5 questions, please. E power sine inverse x and 1 minus x square root. So 7.6, same section we discussed already. 85 question, please. Integrate 3 raised to power sine x. That's so. Yeah, please.
How do you know you 7.6 or exponential or like the natural relation? How do you know which way to approach?
Yeah, look at it here. 1 minus x square square. 1 minus x square square root and for example, here, this question is. Now, as I told you, means here we need for substitution. What we take as you?
Sine inverse.
Sine inverse, yeah. So let sine inverse x is equal to u. Now, you need the next step is differentiation, derivative. You already have formula sheet of sine inverse derivative, please. So go back to the formula sheet and check, please, what is the formula for sine inverse derivative? Look at here. 1 over 1 minus x square root times u derivative. So if you apply the sine inverse derivative by the formula sheet, which I already shared with you, please. So with the help of this formula sheet, right now this is 1 over 1 minus x square root times x derivative is 1. Okay, so it's dx. Huh? And the differential d. So now you can see here that, check please, do you have this stuff in your question?
Yes.
Its value how much? Oh yes, this is my requirement. This is the stuff I have here. So dx for this one is simply. So now this is integrate. Sorry, this is. Continue this. So integrate. This is EU, and this stuff is what? Now what is? Look at here. What is EU du integration? We learned simply. And please put back u value. And anyway, it's indefinite plus c. What is e for? Sorry, what is u?
Sine inverse.
Sine inverse. So the answer to this question is basically e raised to power sine inverse x and plus c. That's it. There's normal integration. So after substitution, the thing becomes clear. You have to use which technique. You are required the formulas, or you can have the simple normal way of integration like that. Yeah, please.
How do we know that EU is the
Du is
it's not
du always in numerator, please. Never ever in down. Always up.
the EX and the square root 1 minus x squared. It's in the denominator.
The no means this, please. The answer of this whole part is how much? That's it. So yeah, dx for this one is du. Okay. Let's try one more question, please. Take, I think, 92 question, please. 92, please. 92.
That's two omega.
That is,
Two omega.
yes, 2 over radical 3 and 2, yes. 2 over radical 3 to the limit. So what take as you here?
Thank you.
Second inverse and same like before, please. And second inverse derivative, you can check with the formula sheet, please. Means here in 92 question, please. Let secant inverse x equal to u. Now, what is secant inverse derivative, please? Can you check?
Secant inverse is 1 over absolute value
1 over absolute value of u
times
times
of
x squared minus 1 and dx. And u differential?
2x.
No.
Ah.
U differential du, okay? Now, in 92 question, you have some, x values. 2 divided by root 3 until 2. Please tell me from here to here, what is the x value behavior? Positive. So it means
We can remove that.
this absolute value should be removed with sign. Positive sign. So now you can see you have this stuff dx by this one in your question.
Yes.
They don't.
Look at here, dx and this one. Is value equal to how much? Du. So after substitution, you have integrate cosine u because secant inverse x how much? U, okay, and divide by, sorry, not divide, means dx by d should be. So cosine u and du. What is cosine u du integration? Sine u, don't write plus c, we have limits. U value back, what is u? Secant inverse x. So, means now you can place this u value, which is secant inverse, please. So this is sine with secant inverse x, and we have limit from where to where? 2 by square root 3 until 2. And now please do upper limit in the answer minus lower limit in the answer.
You put 1 over the cosine inverse.
1 over cosine.
Feel
1 over cosine inverse.
Okay, so this is basically sine with secant inverse. I have 2, understand? And then minus sine secant inverse of 2 over root 3. Okay.
Isn't the range for second inverse from minus 1 to 1? Range.
Yes, please, yeah.
How can we write the secant inverse on the calculator? 1 over cosine inverse. Does it work?
I got isn't cosine inverse. Maybe it's that's it 0 the answer.
Okay, do you know how to evaluate this part? This part? How to evaluate? I
1
think
over
if you're writing 1 over cosine inverse, you are getting error. Am I right?
Yes.
Hmm. So what is the solution for this problem?
We write the formula.
Anybody can answer the question, please? Because right now you are getting undefined on the
Try 1 over secant. Is this work with the 1?
no, 1 over secant is cosine.
The problem is the range difference.
1 over 2
Ah, yeah, good. Actually, as you experience already means these values are giving you undefined, okay? What is a way to fix this problem is look at it, please. Look at here. I think it's good we interact the situation here. Sine, okay. Secant inverse is aggressive to which function?
1 over cosine.
Cosine. Okay. So look at it, please. Look at how you answer right here. Cosine inverse, and this two, flip it.
1/2.
Oh, come on, yes. You get the answer. Come on. Minus. Do same thing here. Sine. Secant inverse, right. Cosine inverse and flip it. Please, have you read the answer?
Does this work for all of them or?
Or yes, everything. For example, means whenever you have, secant here, sorry, secant inverse or secant inverse or tan inverse, not work. So what you have to do? Take the reciprocal function, flip the value.
I mean, this property where you can.
Yes. Right.
It works for.
For tangent, for secant and secant. The rest are direct answer. Rest are means look at here. So sine inverse also get the answer. No problem. I get the answer, yes or no, please.
Yes.
Okay, one more thing, please. Are you getting answer decimal?
No, you're right.
No. Okay. If you're getting answer decimal, keep this one as it is, please. If you're getting decimal answer, we don't allow decimal answers, please. But you told me you are getting some complete number answer, am I right?
Yes.
Okay, so what is the final answer, please? Final answer.
-1 plus radical 3.
-1 plus
3/2.
radical 3/2 means this is the answer, full answer of the final answer, no?
Yes, that's
Doctor,
Up to
I
you.
think the different sound.
Please check it. Come on.
Plus, and then.
Yeah, I did it. Yes, yes.
I think I got. I think it's 3/2 minus. I am not the same thing.
Please check it. This is the answer of this part or the complete answer?
No, complete.
Same answer? Just check it because many have same answer, please. So that's it. I hope you understand how to fix that problem. Understand? Very good. So anyway, as I told you, please, means these questions basically, you need only one substitution and then you get the answer. Don't worry. Okay? Right. This is about 7.6. Derivative and integration of inverse trigonometric function. I hope you get the idea. Very much. Last segment, please. 7.7. Now we have 7.7. And this 7.7 has also two topics, please. 7.7. The first topic is hyperbolic functions, please. Hyperbolic functions. Hyperbolic functions. Again, we need its derivative and integration. And again, as I told you, you will get the rules for the derivative and the integration of hyperbolic function. Okay, before we start this, we discussed the formulas, the rules of hyperbolic derivative and integration. Let me explain a property of hyperbolic function. Sine hyperbolic x, we call sinh. No sinh. In short, it's sinh and cos. Sinh means sine hyperbolic, cos means cosine hyperbolic x. Sinh and cos can be expressed as exponential function to the base e. Do you know this thing? What is sinh? Sinh is sine hyperbolic x is basically e raised to power x minus e raised to minus x and divide by 2. This is identity for sinh, for sine hyperbolic x. Sometimes we need this identity for the sake of integration. Derivative, you can do it, no problem. For integration, sometimes we stuck. So we have to convert sinh or cosine into this property and then we can integrate. Similarly, cos, cosine hyperbolic x, cos in short. Same formula, only one change we have between them, plus. Please, sinh and cos means sine hyperbolic and cosine hyperbolic have these properties. You can explain, you can express sin and cosine as the exponential function to the base e. And as I told you, in some questions, we require this, transformation. So particularly in the integration. Okay? Right, can you go for this 7 please, because we have to share the formula sheet with the students. So 177 and okay, more next please. Okay.
Yes.
This student integration. These student sheet please. So we need hyperbolic function differentiation and we need hyperbolic function integration. By the way, it is very similar to trigonometric functions. Okay, very similar. Their answer is 100% same, but only the difference comes in the sign. For example, what is the derivative of secant?
Negative cosecant cosine.
No. The trigonometric function. Secant derivative. Secant tan. Now, the derivative of secant hyperbolic is negative secant tan.
Just switch the signs.
So means the results, the formulas of the derivative of hyperbolic functions, the integration of hyperbolic function are very similar to trigonometric functions rules, but their signs are different. Okay. But anyway, don't worry. We provide you the formula sheets for that. So let's go back. I just shared with you. Okay, look at the sheets. Table 7.7 and table 7.8. Table 7.7 is basically the derivative rules of which function? Hyperbolic function. You will get this from the sheet. So no worries. Just follow the formula and that's it. Clear? Similarly, same way. You have here integration rules for hyperbolic function. So before it was table 7.3, 7.3, 7.4. 7.7 table, 7.8. These are, so two tables before and two tables are here. How many tables? Four. Four tables right now are the part of your exam. Okay? So we provide you. So no worries. Look at here. As I told you, I just asked you. Okay, look at here. A cotangent derivative is same. Means cotangent x means the normal trigonometric function. Cotangent is minus cosecant square. And here also cotangent hypotenuse also minus cosecant square hyperbole. Okay. But secant derivative is secant tan with positive sign. But here secant hyperbolic is negative. So basically they are very confusing. So that's why you will give you this on the sheet. Yeah.
These are formulas.
Yeah. Meaning the derivative of hyperbolic functions. Yes, please.
You just, over x minus.
Oh, no. You have memorized. We're talking about this formula. This one?
No, but my question, how do we use this?
Oh, yes. I will show you. Just wait. But this you have memorized, please. It's not provided. It's not the part of that table, please. It's a property, identity. Okay, you have memorized this. Right. So let's take some question. And similarly, look at here. What is the sine x integration? Sine x. Negative sine. But sine hyperbolic integration is positive for sine. So it's very, very confusing. Means if you try to memorize it, in some stage you become confused. So that's why it's better to have the formula sheet, so it's become easy for us. Okay, because the only difference is sign difference. Means somewhere is positive, some is negative. That's why. Right. Sorry. Yeah, means actually whatever I'm sharing with you right now, they are the part of the exam, but not all the formulas. Okay.
No, I mean, this models will come in this time.
Yeah, yeah. Which formula? This one. This I give the sheet. Okay?
Would you have to print it?
No, I will provide you. Don't bring anything. Blank papers I'll provide with the question paper. Formula sheet I'll provide. Okay? So don't bring anything. Just bring your calculator and your stationery. That's it, please. Okay, so let's start with some question with this derivative hyperbolic function, and then Shala will take some question from integration. Okay, let's do 6 for this. Yes, please.
You were not too after the exam.
Over?
Not too.
No, I upload from 2. Maybe today.
You will upload today?
Yeah.
Is it chapter 8?
No. So the rest of 7 section.
2 homeworks for chapter 7.
Yes, we have 2 homework 7. So one you already have and one you get.
How many are not going through? What?
Chapter 7
No, and
overall. 2, 3, 4 or 5. Because in winters and summer, 4 to 5 homeworks we can complete. The rest no.
And it's 20% of the.
20%.
Give us time to show.
About what?
like Excel.
Yes. See, it's like you have 1 week for this one, homework 1. Until next week you can go homework 2. It's fine. Okay.
I think homework 1 is due on Sunday.
Sorry.
Homework 1 is due on Sunday.
Yeah. Okay. So it has to.
Doctor, don't give us time, just make it 30%.
Right, please. We have to find derivative of 25, 26 question, please. Now look at here. This is which, I'm sorry, no. In worse one. Here. So 13 to 24, okay. Let's take any question, please. For example, yes, okay. We can go for 22, please. 22. Y is ln sine hyperbolic v minus half cotangent hyperbolic square v. Okay, 22 question. We have to differentiate, please. Question 22, please. Question 22. Y is equal ln sine hyperbolic v. Okay. ln with the argument sine hyperbolic v, then
Minus half.
minus half
Cotangent.
cotangent hyperbolic square v, right?
Yes.
Find y prime. Find y prime. Okay. This is, I mean, in your questions, hyperbolic functions are involved, okay? And we need this derivative. So don't worry, they have the formula, please. So go to the formula sheet, please. I need, okay, just wait. Because I have natural log function first. So y prime. Same thing. This is the argument, yes or no? So what's the rule for natural log? One argument times argument derivative. Okay. So 1 over argument sine hyperbolic v times the derivative of sine hyperbolic v.
Cosine.
So check this formula. Cosine? Cosine hyperbolic v. Okay, good. So means you can take help from formula.
Is this?
Minus half is constant, no change. Okay. How you find cotangent hyperbolic square v derivative?
Sine.
Change rule. The cotangent has power 2.
It's not on the function. It's only on the.
No, hyperbolic function.
Oh.
We put the power something on hyperbolic. Okay. Please, this is cotangent hyperbolic v square. Complete square. Okay. Use chain rule. N x n minus 1 times x derivative. Chain rule, please. So this half the part of the question.
Then you
Now
write
start.
2.
And
Then you write it again.
and so 2 minus 1.
1.
1.
And then you write
The derivative of cotangent hyperbolic V.
Negative
Please check
cosecant.
the formula, please.
Negative cosecant.
Negative cosecant hyperbolic V, right?
Square.
Square.
Square. The derivative is square.
Oh, cosine is minus cosecant hyperbolic square. Yes, yes. This is the derivative of cotangent hyperbolic, yes. Okay. So it is negative cosecant hyperbolic square, exactly
You
right.
cancel two with the.
Now, start the simplification, please. This and is gone. And now, actually, there's one more thing, which is called identities of hyperbolics. There's one more table where you have identity because this is not the trigonometric function, strange hyperbolic function. They have their own identities. For example, sine square x plus cosine square x is equal to how much? 1. In hyperbolic, cosine square hyperbolic minus sine hyperbolic square is 1. So now we have two
You
options.
will provide that.
Either I provide or you have memorize.
Provide.
No, I think it's better we don't use identities.
Yes.
Okay?
Keep it like
I
this.
don't give to anything to the exam. Okay, so it's better means no need for identities. Whatever you get, if some cancellation, make cancellation. But for identities purpose, keep as it is.
Does the cosine be, sine be
Tangent. Yeah, tangent. Exactly. Sorry, cosine sine is cotangent. So this is now cotangent hyperbolic V and negative how much? Positive. So you have now cotangent hyperbolic V times cosecant hyperbolic square V. Do you understand? Yes or no? Because I think there is identity which we can use here. What I can take is an odd factor. Cotangent hyperbolic. So it becomes 1 plus cosecant hyperbolic square.
Just call.
Shama, please, ready. Just check the table, share with us, I showed them. We have identity table, first one, the first one, identities. Yeah, can you share, please? So I just show you the, identities, please. So
But you will not need them.
there are two options. Either you have to memorize or I have to provide.
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 No need for identities.
So you don't have to use
So
them.
start the exam.
Sorry.
We don't have to use them now.
Yeah, no need for that. Same one. You sent, please?
Yes.
Okay, it's coming. Look at it. Look at it. These are the identity table, please. Look at it. Cosine hyperbolic square minus sine hyperbolic square is 1. In trigonometric, it is cosine sine square plus cosine square. Where it means they have different, so it's very confusing if you try to memorize. Okay. Now, what I was talking about you means if I take here cotangent as common factor, I get 1 plus cosecant hyperbolic square. Okay, just check. Is any identity 1 plus cosecant square hyperbolic? Check this. Where?
Last one.
What? Okay. So that's why I told you means we have some identities related to hyperbolic. Okay, it's okay. I agree. Okay. Means stop here. It's fine.
as a person, they may tell us.
Oh yes, in Pearson you have to go with the correct format. But anyway, because it's not exam, so you can take help. I just told you this table number is 7.6 is related to the identities, please. Hyperbolic functions identities. Okay, please. If you have homework, you have hyperbolic questions, and identity is applicable. Please take from here. Good enough? Good. Right. Let's take
It's not
that.
included in the exam, right?
Sorry.
It's not included in the exam.
Yeah, we don't apply. Miss, for that was, let's stop the answer, this one. Okay, but as he asked, maybe the homework, the answer is with identity, so you can take help from the identity table. Right. So for me, see like that, okay, now I'll not show you the something. 23 question, please, 23. 23, please. Write the question first of all, 23, please. Then I have to say something here. x squared plus 1 times secant hyperbolic with the number, the value, ln x. 23, please. 23, I just write for your reference, please. What's 23? 23, please. Y is equal to
X squared plus one
x squared plus 1.
times secant h, then h. And plus one.
Okay. Secant hyperbolic with a value ln x, right?
Yeah.
We need y prime. We need y. Okay, please. In the starting, I shared with you a property of sinh and cos. Remember?
Yes.
We change into what? Exponential function to the base e. Okay, you asked the question that where we have to change or not. Okay, please look at here. I give you, means the situation where you can use this conversion, please. Whenever you have with hyperbolic, you have ln x, please use identity.
I want the equation reverse.
Yes. Whenever with any hyperbolic function, ln x is involved, please use the identity. Which identity? The base e. So right now it is secant. So secant is a reciprocal of which function? Cosine. So you need cosine hyperbolic function identity as a reciprocal. Means, look at it please. So please, don't start differentiation. No. First we convert this secant hyperbolic into base e function. What I told you, if with hyperbolic function natural log is involved, it's better. By the way, you can differentiate without this conversion. You can differentiate. You have the formula with you of secant hyperbolic, am I right? But please, if you use the identity, your answer becomes more precise and easy. So we don't start the derivative, please. First, we simplify it. How to simplify? As I told you, secant hyperbolic will convert into e raised to power x, whatever the formula is. But secant is a reciprocal of what?
Cosine.
Cosine. Go back. It's not available. You have to memorize. What is cosine hyperbolic x equal to what?
E power x.
E power x
Plus.
plus. It is plus e power x divide by 2. Now, secant is a reciprocal.
So it will be two.
So it's flipped. It becomes 2 over.
E power x.
Yes.
E power negative.
Very good. So please don't start differentiation. First, we need simplification. Okay, look at here. X squared plus 1 times. Now, please look at here. Look at here. This portion basically, it is working as cosine hyperbolic x. Just for reference, I am giving the formula. E power x
Plus.
plus e power
Negative x.
divide by 2. Okay, please look at here. With hyperbolic, what we have, it is in the power, please. You understand? Okay. I need secant. So cosecant, how becomes secant, please? Reciprocal. So for secant, please, secant hyperbolic x is a reciprocal 2 over e power x and plus e power minus. Understand point? Right now, in my question, this x is how much? ln x. So please, wherever you have x, replace with what?
And
ln x. Very nice. ln x, please. I also replace here. Look at here. Do you understand what I did here? I just, use the identity. This identity I used for my question. My question was secant. I reciprocal the cosine plane. Then this part is x, which is ln x. So wherever you have x, we put ln x. Now I think you should calculate. What is the e power ln x? Come on. Very good. And e power ln x.
1 over
1 more. So please, you have almost got the simplification. This is now this one, which is basically equal now to divide by x and plus what test? Yes or no?
Yes.
Get the idea, please? I didn't start the derivative. I'm just simplifying first, please. Okay.
How did you simplify this? What?
See, first of all, I use the property. I got this one. Now just like e power n x. No,
It cancels the line. So
use the calculator is fine. Why you say done? And similarly, e power 1 yes, 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 check please. Okay, I'm sorry, I mean this is product. Here is here, x squared plus, and then times 2 this, okay. Here, how simplify, please?
Times
Common denominator, so become this one, right? Okay. Still, I have not started differentiation, please. So 2 times, look at here. 2 times x squared plus 1. And then now in the divide, I have here divide common denominator. What is that? X squared plus.
Bring the x.
Now this divide will change, right?
Can you cancel?
Ah, yes, yes, you can discuss, no problem. Let me finish proper way. So 2 times x squared plus 1. This divide change to what? So this one there, x divide by x squared plus 1. What will happen? Next.
cancel x square plus n.
So what are you getting finally? 2x. What is 2x derivative?
2.
So see, if you use property in this case, the derivative is nothing, it's just y prime is 2. That's it. So y prime is 2. Do you understand the usage or benefit of this property? And tell me, when we use this property,
When you have this.
when we have hyperbolic part ln, then use. Otherwise, it is a waste of time, please. Even if you use some other, way, it becomes more complicated. So always use this property when the hyperbolic function of whatever you have for secant, cosecant has ln x. Then it becomes very simple, like here. Yeah, it's just 2x and 2 is negative 2.
Can you go on? The square, like the x square over x, the square came from.
Oh, actually, I make the common denominator here. Basically, it was like that. X plus 1 by x.
Yes.
So I need the down part same. What should I do? I multiply down x, multiply up x, x how much? Yeah, that's one. I hope you understand. I'm sorry I go directly, but to make the common denominator, but in x.
No, you make that stuff to make that denominator.
Yes, 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 yes. Exactly. So let's take one more question, please. Anyway, it means there's nothing. For example, here, 24 question. Average function has what? Ln is there? Ln?
Yes.
Please, what do you do?
Use the property.
Use the property here. Before derivative, please use a property, simplify it. I'm telling you, the question becomes very, very straightforward. Maybe it becomes x square only. And x square derivative?
2x.
That's
Here for the cosecant, we will use the sine.
cosecant is a reciprocal of
Sine.
sine. So 2 over e power x minus e power.
And the powers will be ln 2x.
Yes, ln 2x. E power ln 2x minus e power minus ln 2x. Use calculator, gives answer. How much e power ln 2x? Check. E power ln 2x, how much? I think it is 2x. Yes or no?
Yes.
And e power minus ln 2x is 1 over 2x. Okay? Right. Yeah, please, please. Yes, no one.
We want over.
Exactly. Not, 1/3 is the formula is now reciprocal. Actually, if you look at the formula of sinh and cos, they have e power x minus e power y divided by 2. Cosecant, 2 become go up and e come down. Hope you understand. Good. Nice. Okay. Please. Now. These are the derivative of this function. Which function derivative? Hyperbolic. Derivative of hyperbolic. Now, just take some question. Integration of hyperbolic, please. Integration. Again, formula sheet is with you. Okay, don't worry. You have formula sheet, please. You have the formula sheet, please. Don't worry, please. Okay, let me decide a question, please. Okay. Do you know? Okay, I asked the question. I'm writing it, please. Give me the integration of cosine squared theta d theta. We have done in the Calculus 1, huh? Okay, yes, the boy side. How to integrate cosine squared theta d theta? That's great.
U equals something.
Solution. Yes, please. I'm asking this side, boy side, please.
Plus
How you integrate cosine squared theta d theta? And similarly, sine squared theta d theta. I'm asking.
identity.
Okay, now girls, please, no.
Property, which is 1 minus sine squared x.
Okay.
Yeah, the cosine, the 1 plus 2.
One.
Plus 1 plus half, and it's sine, you switch the sign.
Yeah. Direct integration of sine square cosine is not possible. You need identity. And that will be 1 plus cosine 2x or 2 theta over. Okay. Similarly, in hyperbolic function, if you look at 59 question and 60 question, they have squares. Mean they have cos squares and sin square. So you cannot integrate directly with the identity. So identity table I shared with you already. Yeah, means. So please, don't confuse with these two questions. These questions need identity table. Where is that? So, oh yeah, cos squared. What is that? This identity you use for the purpose of integration of cos squared and sin squared. Understand is to know the same like geometric function. You need identity of this one. And look at the difference. Here is 1 plus cosine 2 over 2, and here, and here, sorry. And hyperbolic, please. In hyperbolic, look at here. It is same. It's positive. But in sinh, it is 1 minus, but here is cos and minus. So, very confusing.
Does that tell you not to bring?
Yes, I told you, it means we avoid this idea. Otherwise, I have to bring this table in like exam and also all you have to memorize.
No.
That's the question.
Okay, anyways, we are talking about integration of hyperbolic functions. So just to avoid confusion, I told you these two questions need identity. Understand point? Okay, good. Let's take other question, please. Okay. So where is that question which I am searching? Oh, yes. Yes. Okay, before I go that question, which I am particularly interested, let's take a normal question so that you can understand this, integration of hyperbolic functions. Let's take 52, please. 52. Come on, 52 question we have to discuss now. So this question we are talking about now, this is integrate 0 to n and 2. And I have tangent hyperbolic with the value 2x and dx. Yes, please. If you know the tangent integration in calculus 1, you can easily answer here. What is the way to integration of tangent? Huh?
Sine.
Yes, good. So please, step one, change into sine. Sine hyperbolic 2x divide by cos 2x and dx. Okay, good. Next step,
We use fusion.
we use substitution. Very nice. What to take as you, please?
Because it takes time to be.
Yeah, cosine hyperbolic 2x. Take cosine hyperbolic 2x as u. So please, next step is substitution, please. So cos 2x is equal to u. Now, next step, we need derivative of cos. Please, you have the formula sheet. Open the formula sheet. Tell me what is the derivative of cos? Means cosine, hyperbolic derivative, how much, please?
How about your X?
No, please. Derivative, please. Derivative. It is negative? No.
Decided.
No, please. It's not trigonometric function. Hyperbolic.
No, sorry. Is this one?
Seven.
This one?
Yeah.
Okay.
It's positive. Negative, positive.
It's-
Positive. Okay, so cos means cosine hyperbolic 2x is how much? Sine hyperbolic 2x times derivative of this part. How much? 2 and dx is equal to d.
And then you divide by.
Oh, yes. Now, in my question, I need only since 2x dx. So what is extra in my calculation?
2.
2. Yes, take the sign or divide by 2 both sides, please. So this 2, please, I don't need. What I do? I take what? Divide by 2. So what is the numerator answer?
1 of you.
du divide by 2. Very good. So please put back now substitution here. So after substitution, integrate. This is du divide by 2. Divide by 2, I take outside because it's constant. Yes or no?
Yes.
And divide by, what is cos 2x? U. And tell me, what is du by u? ln. Oh, nice. So I have half ln absolute value of u. What is u, please? Cos. Cosine hyperbolic 2x. And please don't forget, it has limit.
From.
From where to
zero
where? 0 to ln 2. Very good. Please try. Put the upper limit in the answer. Means cosine hyperbolic 2 times ln 2.
How do you put cos?
Minus. You can, yes, it's there. Put HYP. You have a button.
Yeah,
HYP.
and then you put the.
Yeah, but if it is coming decimal answers, don't write the answer. Keep your answer as it is. Means as it is means like please put the upper and lower.
Look to the left.
Let me write here the question number 52 here, please. So you have done, it is 1 by 2. What is that here? ln. Cos, cosine hyperbolic 2 times ln 2. Am I right, please?
Yes.
Upper limit.
Yeah.
And minus. And minus half ln cos. 2 times 0 is 0. So please, you have the option in your calculator. Have you found
That's one. So.
HYP? Yeah,
No,
please.
it's not then plus one.
Okay, so no. Tell me, what is the answer of cos 2 ln 2?
I
Come on.
got 17/16.
Okay. If you are getting fraction, very nice. So use that fraction. If you are getting decimal, no, don't use any decimal, please. So keep as it is. But you told me the answer of cosine hyperbolic 2 ln 2, how much?
17/16.
17 or 60, very nice.
And 0.
So it is 1 by 2, then ln, right?
Yes,
and-
no, I didn't get.
No, yeah, I just want to know only the answer this part. Or you also apply ln. Go on, please. Can you check others, please? What is the answer of,
Yeah, 17.
17 over? Very nice. Minus 1 by 2. And then what is cosine having 0?
1/2.
Okay, sorry. 1 over 2. Very nice. until here. You understand? I don't know. Check please. 17 by is 17 by 8? Okay. Please correct. They told me 17 by 8 means cosine hyperbolic 12 into is 17 by 8. Is that correct?
That's one.
It's 1.
Yes.
Okay. It's not half. So it is 1. Please make correction. They told me cosine hyperbolic 0 is 1. Correct? Okay.
Yes.
Now, ln1 we know very well how much. ln1 is 0. So this part becomes 0, please. Finish. It's a 0. Finish, please. Okay. Come over here. Over here. This is now 1 by 2. Actually, that's it. Keep, because I can write ln 17 minus ln 8. No need for that. So half ln 17 by 8 is the answer.
Actually, how do you get this?
How to?
I'm getting this one.
No. I don't know. Ask them, please. Don't have the answer. Lesson number 12. Corrections. Don't put everything together. No. One by one. Please, step by step. Then you get the answer fraction. Okay? You know how you understand now? Please. Yes.
Still have the elements. When we write the element, just remember.
Because I have basically two functions together. Look at. I have ln. I have cosine hyperbolic. This is an argument of ln. Same here, exactly. It's an argument. I'm sorry, it means I can put the bracket here. It's argument. It's argument, please.
That's why I was confused.
Don't confuse, please. Don't, because there are two functions: natural log and cosine hyperbolic. Please. Now it's correct. Check, please. Can you help her, please? She's not getting the required answer which I'm getting now. No, please. If you have the option of subtraction, we have to go. Please. Sometimes, yes, sometimes means the answer is fraction, decimal. So stop here. But don't write decimal answer. Yes, please. Oh, yes. No, right.
But the example, give the same thing.
Okay, now I hope you understand the integration of the hyperbolic function. Okay. Now, one more question I have to share with you, please. We know in derivative questions, I told you when you change into e, when the hyperbolic has ln. Okay. Now I will tell you when you change in integration question to e. Okay. Look at it, please. 53 and 54, same pattern question, please. Here you have cosine hyperbolic, here you have sine hyperbolic. Okay. 54 I answer, okay. Because 53 is a odd number, you can check the answer. Let's start 54, please. 54, which I answer. Please, 54. Question 54. This is integrate. And it is 0 to ln2. 0 to ln2, please. I have 4 e power minus theta and sine hyperbolic. So 4 e power 4 times e power minus theta and sine hyperbolic theta and d theta. Okay. What we need here? Integration. Okay. Now, please, how we integrate this? We have two functions now: exponential, base e, and sine hyperbolic.
Sine hyperbolic.
Can you take some u right now, substitution?
No.
See here, for the purpose of integration, if I take sine as u, what is sine derivative? Cosine? Do you have cosine in your question? No. You don't know what. If I take e as u, what is e derivative? E power minus theta times minus theta. So again, I don't have e. Means how I cover sine. So in that case, basically, how you integrate? Please change because this is base E. Sine hyperbolic can also be converted into base E. Yes or no? Understand? Good. Give me the rule of sine, please. In E. I have shared already with you. You have to memorize. This 4 is constant. Keep outside. E power minus theta is my question. I want to know is what is sinh? E power now is theta. E power theta. Minus e power minus theta over 2. Very nice. I hope you understand how and when you convert this sinh and cosine in E. Understand point? So whenever in integration you have E function with you, and next is any to remember means any hyperbolic function like sine, cosine, cosecant, cotangent, you cannot work unless until you change into E. Now there is no hyperbolic. All are what? E, base E. So first simplify and then we integrate. Yes, please.
So after we use this proof in two cases, whenever we have many.
In derivative case. In derivative case, if the hyperbolic has ln, change into E. And here in integration, shall we use E? Understand now? Okay, please simplify it first, please. This two we can cancel. This two gone. Right? Now we need simply multiplication of E power minus theta with this one and that one by one piece. Multiply and then the answer. So 2 times integrate 0 to ln2. E power minus theta multiply E power theta. E power minus theta and plus theta. Because it's the same basis, power add. Yes, E equals 0, which is 1. Yes. Okay, come on. E power minus theta multiply again E power minus theta. So E power minus theta again minus theta. So please, this is the output. When I multiply this by this and this by this, I got this answer. Do you understand? Is that clear? We simply multiply this by this and this by this. So I got, because when you multiply the same basis, powers add. Powers add. Okay? Yeah.
The first E, we added one, in the second E.
Oh no, look at this. That's fine. You have 2 things. E power minus theta multiply E power theta.
Okay, so we add.
So powers add, powers. So minus sign the question, the minus sign. E power minus theta multiply again E power minus theta. The powers are add.
So it's plus minus.
Exactly. Okay, so now we have here. Okay. Now, 2 times integrate 0 to ln2. This is gone. E power 0. 1. Very good. Minus E power minus theta minus 2 theta and here's d theta. Okay. Please distribute 1 by 1. Integration 1, integration E power minus 2 theta.
Theta minus.
So now we have here 2 times integrate 0 to ln2. 1 times d theta is d theta. Minus sign again 2 times integration of E power minus 2 theta and d theta. I just distribute, okay? Integration of this, integration of this. Clear? Also 0 to ln2. Okay. What is d theta integration? Theta. Yes. So it's 2 times theta, and don't forget it has limit from where to where. 0 to ln. Now for the integration of this one, let's take substitution. So let's take minus 2 theta is equal to how much? U. Now minus 2 d theta is equal to d. I need only d theta, please. So divide by minus 2 both sides. Cancel. What is d theta? Negative du divide by, put here. I have already -2 in my question. Integrate e power -2 theta is u. What is d theta? Negative du divide by, so this is du and divide by -2. So this cancel, minus, so plus. That plus. Okay. Now this one already we have done. So in the last we have to substitute upper and lower limit. Okay, we do each other, don't worry. Plus. Okay. What is EU du integration? EU. And what is u I have taken? -2 theta. It has integration, sorry, limit from 0 to ln. That's it we have done. Now just simply upper limit in the answer minus lower limit in the answer. Okay, start please. 2 times ln 2 minus 2 times 0 because lower limit is 0. Understand?
Yes.
Come on. E power -2 times ln 2 minus e power -2 times 0. Please, I just substitute upper and lower limit in my answers.
That's why did you do it separately?
Easy.
Oh, it's up to you. You can use in one or you can use separately. Both are correct. Don't worry. Okay, please, just give me the answers, please. Come on. Where's the answer? Last answer. Square 2.
Plus here.
This is 0. And here is 1. Am I right? How much is answer?
Plus 1/4.
Plus 1/4. Okay, good. And here 1. Right? Okay. Now, what we can do more? Okay, 1/4 minus 1 you can combine. Yes, how much? So this is, I think in your book, they moved this to as a power. I mean, they said it is ln what?
4.
4. 1/4 minus 1. Yes. -3 over. That's it. This is simplified answer. This is simplified answer. Please.
So if you leave it 2 ln 2,
It's okay. If you keep 200, it's fine. Don't worry. But I'm just giving the homework answer. In homework, quite possible. They move this as a argument power and make it 4. Okay, because 2 power 2, how much? 4. That's why. Both answers are correct. Don't worry. Please, this is the way when in integration you convert change to exponential. Because you have exponential function already with you. Do you understand, please? So this is our topic number 1 in 7.7, derivative and integration of hyperbolic function. We have one more function in 7.7. What is that? Inverse hyperbolic means same like trigonometric function, then inverse trigonometric function. Same here, hyperbolic function, then inverse hyperbolic function. And again, same target. We need now derivative and integration of inverse hyperbolic function. And again, no worries, you will get the formula sheet. Please share with us the derivative and integration rule of inverse hyperbolic functions, please. So please, my discipline. This is these are questions. These are the questions related to say 41 to 60. All are questions related to the integration of hyperbolic function. It's simple, just like trigonometric functions integration. Not any difference, please. Don't worry about that. Now, yes, we should this. Okay, look at it, please. Look at it.
there's one thing.
So 7.10? Oh, yes, here.
And there's another.
Yes, thank you very much. Look at it, please. Table 7.10. You can see the, derivative of what? Inverse hyperbolic function. So again, no need to worry anything. Just copy the formula. That's it, please. Sorry. This is the inverse hyperbolic function derivative studies. And we will provide you an example.
The example of 7.7.
Always one, yes. So is there in Teams, you can download, you can save, and now we use them, okay? Same like before. Let's start the question from here. Again, I told you means u is that same like trigonometric function. U is that part which is a part of the hyperbolic inverse. That is u. You need this u here, and at the end you need its derivative. Same like before. There's no change real. There's no change in concept. Please. It's same like before. Again, you have absolute value. If you have information about u, remove the absolute value. If no information, keep as it is. Clear? Right. So let's take some question now about inverse hyperbolic function derivative. And here, 25 to 36. These are the inverse hyperbolic questions. Let's take a question, please, quickly. And we use a formula sheet, and that's it, please.
Is that integration?
Sorry?
Integration.
And we have also integration. Yes, yes. First, let's finish this one. Derivative of inverse hyperbolic functions. Okay, I think we can start with 32, please. Let's start with the question first, and then we can go for further. One more question we can take, no worries. Okay, 32, ln x and 1 minus x squared secant inverse. Okay, please just dictate me, please. 32 question, please. 32. 32, please. Question 32, 7.7 section, y is equal to ln x, yes,
Plus square root
plus square root
1 minus x squared
1 x squared
times secant
secant inverse hyperbolic
and x.
x. Okay, find y prime. Find y prime. Okay. Don't worry, please. Same rule of differentiation, please, which we have learned already. Hyperbolic inverse, they are provided to you. So don't worry. Now start y prime. ln x, yes.
1 over
Very good. Plus, here, two functions have product. Product rule. Exactly. So drive this one, shortcut, 1 over 2 square root of 1 minus x squared times negative 2x. And inverse hyperbolic function copy paste as it is. Yes or no? U prime v, we are using product rule. U prime v and plus now u and v prime. V prime means secant inverse hyperbolic function derivative. Open the formula sheet, please. And help me, what is the derivative of secant inverse hyperbolic? This question, this is the rule. Negative 1 over u times 1 minus u square, okay? And times u derivative, which is 1. So, yes, please. How I write now? Yes, please.
negative.
Negative. Okay, so if you don't mind, can you change this plus to negative?
Yes.
Can you change it? Because in my rule of secant, it's negative. Okay. Negative, yes, next.
Negative 1 over u, which is
X
yes
times.
times square root of 1 minus x squared.
That's it. That's it. I differentiate my secant inverse hyperbolic derivative by the formula. Please, formula sheet. Please.
The derivative of u of the x.
What is the x derivative?
I thought the x. Inside.
No, inside is that. Only this one. I understand this.
So we only the derivative for the x.
Exactly. Because my u is x. In secant inverse hyperbolic function, my u is x.
We have, for instance, x squared.
X squared, so 2x.
2x. Should
Clear? Very good. Now simplify. What we can do? This count? Yes. Yes or no? This to this trigon? Okay. After this cancellation, I have 1 by x. Positive times negative is negative. This is x times secant inverse hyperbolic x. Divide by 1 minus x squared. It has square root. And minus 1 over x times square. Oh, sorry. So only 1 by x, am I right? Any more assumption?
Yes.
You can count this one,
Oh, yes, this one. What is y prime?
negative x.
That's it. Y prime is negative x. Secant inverse hyperbolic x and divide by 1 minus x squared in the square root. I hope you understand. Any problem? Just follow the formula sheet and use the product rule or quotient rule or same power rule, chain rule. You have learned already. Yes, please.
Beside the second, we put, no. Why did we change the sign from positive to?
Because look at the formula sheet. Secant inverse derivative is negative. It has negative sign. That's why. Clear? Very good. So please, it's not any different thing, please. Same like inverse trigonometric functions. It's same like that. Just follow formula sheet. Understand this? Good. Let's take one more question. And then we start last topic, which is integration of inverse hyperbolic function. Okay? Right. I think take 36 because no. Let's have cosine has the take please. Cosine has absolute value in the derivative proof. Cosine has absolute value.
No.
And the derivative.
Okay, no, it's fine. No problem.
Only cosecant.
Okay. Right. Anyway, 33 and 34. Look at it. They're same pattern question. Question one. Can we go 34? Okay. 34, please. 34. Please just give me the 34 question, please. Question 34. Y is equal to how much, please?
Cosecant.
Cosecant inverse hyperbolic to the power theta. Okay. We need y prime. We need y prime. Y prime. Okay. Now, please tell me, do you know what is the u? If you look at the formula sheet, they said cosecant inverse hyperbolic u.
Yes.
What is u in our case?
2 power 3.
Power theta. Yes, good. Our u how much? 2 power theta. So please don't worry. Open the formula sheet. Wherever you have u, substitute 2 power theta.
Can you continue?
Wait, please. Just I give you an easy way. Okay, so don't change right now. Otherwise, it becomes complication. Okay. So start now, please. Y prime. Come on, give me the formula sheet, please. Yes. How start? Negative. Okay. Yes.
1 over absolute.
1 over absolute value of
Power
u.
theta.
Yes. My u how much?
2 power
Great. Okay. Next, please.
times 1
Times square root. Yes.
1 plus u square.
1 plus u square means 2 power theta and square and times the derivative. Oh yes. Now please look at here. Now you need derivative of u. My u is based how much? 2 power? 2 power theta. Go back to 7.3.
A.
I have base A differentiation not possible. We change base A to base E. Don't change any other things. Wherever you need derivative, this part only change base A into base E so that we can derive, we can differentiate. Okay. So please, this one, tell me how you change 2 power theta.
A power theta. E power
A
theta.
power theta times ln.
2.
I hope you understand where you have to change.
So the theta is a power and the 2 is.
Same, conversion formula. A power x is basically E power x times ln. This will be used here.
That's 7.3.
3, yes. Hope you understand. Okay, that's it. Please write this one. E power theta ln 2 derivative how much?
E theta.
Okay, so here we have like sine 1 over 2 power theta absolute value, then square root of 1 plus 2 power becomes, can I write the 4 power theta? We don't mind. Means 2 theta power 2. Not 4?
No, it can't. Oh, it's two to power. Yeah, but the theta is multiplied by the two numbers.
I cannot write this one.
The power is
So power theta as 2 and theta.
It's the same. But
Yeah,
it's
so-
flip.
Tell me. Theta times 2 is 2 theta. Theta power 2 is how much? 2 theta? What is that?
Two theta also, the same. Oh, four.
Yeah, it's a 4 power theta. So this one I can write as 4 power
No,
theta. Okay, times please, time. Okay, give me the answer here. E power theta ln 2 times
And then
ln 2. Okay. Right, now please look at here, look at here. I told you already, my question was not in base E, in base A. How I changed E power theta ln 2 into, yes, tell me.
two to the power.
2 to power theta. Okay, very nice, good. You have done all these things already, right? These things we have done, 7.3, please. Okay. Look at here. Absolute value of 2 power theta. Okay, please. 2 power theta, sorry. 2 power theta is which function, please? Is which function? No, no, is which function? Exponential. Do you know the property of exponential functions? They are, I told you already, exponential functions are positive function. So please, absolute function, oh, sorry, exponential functions are positive function, please. Their answers are above the x-axis. Yes or no?
Yes.
So you can easily remove the absolute value and we can cancel. This is this gone, and now finally, what we are getting is
Negative.
y prime is equal to negative sign ln 2 divide by square root of. By the way, means if you put this one like that, no issue, no problem. You can like that, it's fine. Okay, sorry, was that 2 theta and square? It's okay. 2 theta and square. Please, no worries. 4 power theta or 2 theta power, they're same thing. Don't worry, please. You understand? Please.
Can you repeat why we don't need anything?
Oh, please. The derivative of base E, copy paste same function. I'm sorry, I changed it back. E power theta and then 2 multiply the power of the derivative power. Multiply derivative of the power. So ln2 is constant, E as it is, what is the derivative? 1. Dash or greater. Now it's clear? And please, we put back this one, the base E to base A. Yes.
Because it's not.
In our question, we don't have base E, we have base 2. That's why. That is cancelled from here and here. Okay? Understand now? Good. So please, this is the story about derivative of inverse hyperbolic functions. Understand? Now, last topic. Integration. No, we have time, don't worry. It's not anything, please. Last topic. Integration. Inverse. Because you have formula sheet, please. No worries. You have formula sheet. You have formula, please. Look at here. Formula. So formula of integration of the inverse hyperbolic function is here. Look at it, please. This is a table for integration of inverse hyperbolic function. Means actually you cannot integrate hyperbolic function directly. Means in the answers you are getting inverse hyperbolic. Same like 7.6. Means as an answer, you are getting sine inverse x, you are getting tan inverse x, you are getting secant inverse. Same like here. As an answer, you are getting sine inverse hyperbolic, secant inverse Hubble line. So please, this formula sheet will be provided to you. So you only have to check my question is matching to which.
Sir, at the beginning, there was only three, sine, tan, secant.
Not really, in 7.6.
I mean, yes.
Yeah. So 5 more.
First one,
Which one did you guys?
the number three.
No, it's not is a function, it's an integration option.
Uh-uh.
Number 3 has 2 possibilities, okay? So we have decide which is the answer of the question. The answer of the question depends on this condition. If this condition true, use tangent. If this condition true, use what? Cotangent. So basically we check. We check in which cases, in which case, in third case, when you have constant square minus function square. So it has 2 answers. Now means 2 options. Then we check the condition. If this condition true, answer is tangent inverse hyperbolic. If this condition true, answer is cotangent inverse hyperbolic. Please.
There is this answers. Like,
No, because all they have only one answer. Look at here. What's the integration of this answer? Sine.
yes, I.
So no difficulty, no need. Oh yes, here we have 2 options.
So,
That's why we have to use. We don't know. This is the answer, this is the answer. So we have to take help with the condition now. Others only one answer. That's it. No problem. Answer mind. Yeah, okay. So let's start next. I think can we go directly with this third condition? Huh? Okay, I think yeah, we can start with the third condition first. So get here, question number 70, please. 70. 0 to half dx by 1 minus x squared. Okay. So we are now discussing the integration of inverse hyperbolic function. Question number 70, please. Integrate 0 to half. Okay. So 0 to half
Yes.
dx divided by
X squared.
1 minus x. Actually, by the way, they have given very straightforward question. Okay. Now look at this, please. Here, 1 I can write as 1 square, right? 1 you can consider as square. Any problem? No. Okay. So this is my a square minus this is my u square, right? A square minus u square. Open the formula sheet. Which case? First, second, third, fourth, fifth.
Third case.
Third case. Now third case has two options. Either it is tangent or cotangent. Okay, good. Now please. With the rule of third, you have some conditions. What's the condition, please?
the,
If a square is constant square is greater than function square, so answer is stated. If constant square is less than function square, so answer is cotangent. Understand?
Used to it is.
Yeah, let's wait. What is my a?
One.
Very good. 1. I need now my u. Now I need my function. Okay. 0 to 1 by 2 are the value of what?
X.
X. These are my x values, my function values. So please, as per the formula sheet, a square is greater than. By the way, my use x square. Don't worry. So if a square is greater than x square, you have to use tangent. And if a square is less than x square, you have to use cotangent. Here is tangent, please. Inverse. And here is cotangent. Okay. As I asked you, what is my a? You told me a is 1. What is a square? Well, 1. Now I need x square. Start, please. This is my starting value of x. What is that?
0.
Make it square. What's the answer?
0.
Okay. What is my highest value of x?
false.
Make it square. What's the answer?
4.
Okay, now please compare.
Is it?
My A is 1 and my X square is 0. Who is big? A is big or X is big?
Done.
No, I'm just comparing, please. Okay. My A is 1, my X is 1 by 4. 1 is big, 1 by 4 is big.
1.
1. So please, my A is big. If A is big, which rule? Tangent. So that's it. The answer is tangent.
If they're both equal.
No, not possible. Only one thing is possible, please.
What if like one of them is smaller than
Not possible. Not possible. Not possible. If it happens, wrong question. We have this situation in chapter 8, section 8.8, which is called improper integral. So we handle the situation there, not here. So tan inverse hyperbolic, what's the root, please? X. Come on, what's the root? Complete to me. No, in the starting you have 1 over A.
1 over A.
1 over A. My A is 1. So 1 by 1, no need, okay?
What?
So tan inverse X over A. The A is 1, no need. It has limit. Where? 0 to half. Come on, put tangent inverse hyperbolic. Upper limit how much? 1 by 2 minus lower limit how much? 0. When 0 comes here, I told you there are two functions who are always 0 and 0. Sine and tan. So basically, lower limit give you 0. No need for anything, please. Take a just check. Are you getting this answer as a decimal? If answer decimal, don't write decimal.
Yes.
Decimal, don't do anything. Stop here. This answer. If you are getting decimal, don't write decimal. This is the answer. Tan inverse hyperbolic with a value 1 by 2. Stop here. If you are getting decimal, don't write decimal answer. Yes, please.
The figures. The difference.
In this case, yes. Otherwise, we cannot check condition. Please.
There's some of the difference on here that it's 1 minus x squared, right? Because now I'm confused when.
In the previous question, there is totally different. That is A square plus.
Plus.
Very different. They're not saying, no. That 3 and this 5, totally different. No matching, no. Be careful. When you select the formula, be careful. That is A square plus x square, which is tan inverse x. It's a numeric function. It is not. It is A square minus. Yes, totally different. Okay, now we can check one more question, please. Here. So look at here. 69. Come on, try yourself. 69, please. Take the question 69, please. 69, please. So again, it's very clear. You have A square minus x square. Which rule? Third option, fourth, fifth, fifth one. Third. Again, it has two options. Tangent and cotangent. Check condition, please. Same like I checked before. How much A here? A square is 1, yes. Now check x square. X square means 5 by 4 square, which is 25 by 16. How much?
Done.
1 point something?
Yes.
How much is it?
1.5.
1.5. Okay, my next value is 2. So x square means 2 square, which is 4. Now compare. My A square is 1. But my x square 1.5 is more than A. 4 is more than A. If A is less, tangent or cotangent? Cotangent. Cotangent. So the answer of this question is yes, please.
What if the first one was?
No, this never happened. Never happened. And never happened. Here never happened. Chapter 8 will come. Okay? Right now it never happened. So it is what? 1 over A?
Yes.
So 1 over A is 1. So no need to write. Cotangent. Inverse hyperbolic. X over A, which is x over 1. So no need for 1x. Limit from where to where? 5 by 4 to 2. Yes, please.
Here, even the 1 is less, right, than 2. And if both of them are less, then you would use that.
Yeah, we'll actually condition check. If A is greater than U, use tangent. If A is less, Both of them, yes, yes, yes.
Because they left 1.5.
So 1.5 is more than 1.
Oh.
Come on, please. This is less from both of them. One is less than 1.5, one is less than 4, of course, it's cotangent. Please.
Like both of them has to be greater than one, so we can take the product. But only one will be enough.
Yeah, exactly right, because there's no other question which is has different answers. If you check one point, other is of course.
Like whatever.
Yeah, it's fine. Exactly. Okay, please put upper limit minus lower limit.
This means.
So it's decimal, so the answer for this one, just like cotangent inverse hyperbolic of 2 minus cotangent hyperbolic of how much? 5 by 4. If you are getting decimal, this is the answer. Don't do anything, please. Stop here. I hope you understand how to use this formula sheet, right? So you have to check that my question means my question is matching to home, please. But please, rules are same. For example, in 68 question, what is the x squared coefficient here?
Yes.
None. We know we don't want x squared coefficient other than 1. So you take here common factor.
No.
No.
Yeah. Rules say no change. When you take common factor, then you make squares, you will match your formula sheet with your question, you easily get the formula.
So, for example.
It's easy, not difficult, please. Okay, I have 5 more minutes. If you get 1 minute.
No.
What?
No.
Yeah.
Statements are not.
I'm sorry.
Favors?
Yes.
We can take that 1 question. Huh?
No.
And please, the question are here, please. Huh?
Okay, it's not-
67 to 74 all are related to integration rules, please. Of inverse hyperbolic. Please, you have written now. Try, please. Okay, try.
It's not.
Oh, very good.